Hello, my name is Rilanjan Lod. I'm an assistant professor in the Department of Medical Laboratory Sciences of College of Health Sciences at Marquette University. Me and my colleagues in Zambia, we are proposing a highly sensitive and specific diagnostic test, which can be used as a point of care diagnostic test to detect both human schistosome species commonly found in Africa, called recombinase polymerase amplification, which will add valuable data for the efficacy of surveillance and control program that is going on in Zambia and also in future for the other endemic countries in Africa. This is a true sense of collaborative work between Marquette University, University of Zambia, and Lusaka Apex Medical University. So Schistosomiasis is a very important disease. This is the second most deadliest parasitic disease in the world after malaria, which is a bloodborne and also waterborne parasitic disease. And currently there are almost 220 million people are infected by this disease, and mostly by two species of schistosome, namely Schistosoma mansoni and Schistosoma haematobium. But the current WHO recommended or World Health Organization recommended test relying on the egg detection, which lacks sensitivity, some cases specificity too, and could not determine the actual prevalence of the disease. Diagnosis is really important because you really wanted to know the asymptomatic infection, and we saw like what actually the relationship with symptomatic infection during COVID pandemic. And also if anyone is getting reinfected and any remaining infection, the infection that actually escaped the treatment regimen. This polymerase amplification is a very easy, without hassle, cost-effective test that can be done in the field with no resources at all. So it actually relies on the enzyme called recombinase, and it actually makes the strand displaced. So if you have like a double-stranded DNA, it makes like single-stranded. And then that single-stranded displaced DNA binds with a protein called SSB protein, which actually stops the formation of D loop. And then there's two group of enzymes that comes in, blocking group and detector molecule. So if you do not have like the matching sequence, the blocking group won't allow the amplification. If you have matching sequence, the detector molecule will allow the amplification with help of the polymerase. And when that starts, it happens really quickly within 10 to 15 minutes. And if you have the positive amplification, it will come up on the test line. If you don't, it will not show. It has like limitless opportunity. Because first thing, speed. It can be done within like 10 to 15 minutes. It's highly sensitive and specific, more than PCR or qPCR that's regularly being done in the labs. Temperature does not require any high temperature or zero low temperature. It can be done at regular room temperature. It can tolerate a lot of inhibition, so you don't need any fancy DNA extraction. It has like broad application. You can detect more than two species with this test. It's very, very cost effective because you don't need any fancy or expensive equipment or any robust infrastructure to run the test. It's highly flexible. Anybody can do it without any formal background or training in molecular biology. And the detection format has already been used, for example, Ebola virus, because it has a huge potential. It can be used as a point of care test for schistosomiasis in the resource limited area and mainly in the field where you do not have any other facility to run the complex tests. It can easily be used in the primary health clinic, and it can be incorporated into their programming and also in the main hospitals and the diagnostic labs.